This is the AMCS AERO 1A radar installed in the F-4B aircraft. In this film, you will see some methods of using the AERO 1A to combat electronic countermeasures. These scope pictures were made with the AMCS direct viewing scope camera during actual intercepts. The ECM environment displayed was provided by Project High Speed. This is one type of enemy jamming. In intercepts like this, the most important RIO elements are skill in accurately analyzing the ECM technique the enemy is using, and speed in using your AERO 1A to combat this countermeasure. This bench set will be used to illustrate the use of the controls. Chaff usually consists of bundles of tinfoil strips that the enemy plane or bogey dumps into the air. These strips reflect your radar signals, causing a series of false targets on your scope. The frequency of the radar signals most effectively reflected is determined by the length of the strips. Usually, the strips are cut to reflect a specific band of radar frequencies. Fiberglass chaff is a recent development. It is packaged more compactly and floats longer when released. Chaff is a mechanical countermeasure, not electronic, but it is economical and widely used. Chaff targets look like this on your scope. In this case, the chaff is further away from you than the bogey. The reason is that the chaff, when it leaves the bogey, comes to a virtual halt relative to the speed of the bogey. Therefore, the chaff appears at a greater range in this head-on aspect. In this example, the chaff is closer to you than the bogey, since the bogey is moving away from you. Let's look at a similar situation on the scope. Where is the target in this presentation? With a bogey moving toward you, forward-fired chaff will momentarily introduce a false target between you and the bogey. The bogey then flies through the chaff pattern. You can thus see that a good mental concept of relative motion and target aspect is the key to quick identification of the real target in a field of chaff, not only in this intercept, but in all cases of chaff. Keep in mind that chaff always points to the bogey and can be of actual assistance to you when you use its indications with imagination. Lock on the target as soon as possible. This is a good rule in all types of jamming, since only by locking on can you be sure what type of countermeasure the enemy is using. You may want a break lock to examine target composition or formation, but early initial acquisition is recommended in all cases. Be sure that you're acquiring the real target and not the chaff. A sudden change in the closing velocity to your own true air speed is a good indication the equipment has transferred lock to the chaff. If you suspect that you are locked on the chaff, break the lock, and get back on target. If you're a beam of the target and chaff, move astern of the target so you can get a range rate differentiation between target and chaff. Use the narrow range tracking gate available in the heavy clutter mode or in the normal clutter mode after automatic power level mode switching has occurred. In narrow range tracking, the equipment is less likely to transfer lock to a false target. Barrage noise is scope interference generated by an enemy jammer transmitting over a wide frequency band. The jamming transmitter must be powerful to be effective over a wide band, since spreading the signal simultaneously weakens it on any particular frequency. First, turn down the gain to minimize the noise and prevent scope saturation. This setting will vary throughout the intercept and must be monitored closely. The proper gain setting will leave a small amount of visible noise on the scope, but will allow you to see the target through the jamming at maximum burn-through range. Put the clutter switch in override to keep the receiver in the narrow band and to maximize your transmitter's power. Now, by trial and error, find the polarization that will further reduce the noise. Try circular 1 polarization, circular 2, and linear in turn. The target will usually burn through the noise at usable range. Select the AOJ out function or the gear may lock in AOJ, and you will not be able to range track. On burn-through, acquire the bogey and drive in for the kill. If you lose burn-through after lock-on, and the system automatically shifts to the HOJ operating mode, the attack could be continued in this mode. In this type noise, the transmitted signal is narrow, but is swept across a wide band. Thus, the noise appears intermittently at target line of sight. Swept noise isn't particularly effective, since it can't sweep through an entire frequency band and blanket your radar frequency continuously. Use the same technique as when dealing with barrage noise. Turn down the gain. Find the most effective polarization. Throw out AOJ on burn-through. Put the clutter switch on override if burn-through is lost after lock-on. It may be difficult to lock on between noise bursts. The equipment can automatically go in and out of HOJ. This is a built-in feature designed to counteract swept noise. In spot noise, all the enemy's transmitter power is beamed on the frequency of your equipment. The result is a solid strip of noise that's usually more effective than other noise. There's seldom any usable burn-through. Follow the same procedure as with other forms of noise. Here you see how burn-through against spot noise looks. If there is no burn-through, Make an AOJ lock at short range as follows. Select the automatic position on the track switch. Reduce gain. Point the antenna at the source of the noise signal. Move the antenna back and forth in azimuth to obtain the strongest signal. Then in elevation, and acquire an AOJ lock. Estimate range for missile firing by GCI information, and continue watching for burn-through. It may occur even in the AOJ mode of operation. Do you see the burn-through here? Here the RIO is using the angular rate of the elevation strobe to estimate range. Notice that burn-through occurs at about 2 miles. This is a noise signal that is modulated to include angle track deception. The appearance on the scope in the search mode is the same as with other noise, but angle deception is also present at lock-on. The noise can be modulated at your nutation frequency or at a random rate. Try different polarizations. AOJ and HOJ are usually ineffective, so use the AOJ override. As a last resort, use the manual mode at short range. In this case, the enemy receives your radar signal, then returns it out of phase. As a result, your antenna tracks away from the target. The track presentation has these abnormalities. The B trace moves back and forth. The elevation strobe moves up and down. The steering dot is very erratic. The ASE circle breathes. The equipment may break lock, and you'll have to reacquire the target. Attempt to lock on the bogey as soon as you can. Only lock-on will tell you if angle deception is being used. If lock is broken, or if you're sure the enemy's using angle deception, try different polarizations and lock on again if you can. Use manual tracking as a last resort. But in any case, automatic search operation is not affected. So a sure solution for angle deception is getting in position to fire a Sidewinder missile while in automatic search operation. In this case, the enemy returns your radar range signal with deliberate delay. Thus, 2 video pulses may appear on the scope when you're automatically tracking. The false target moves out in range from the actual target return. Also, you get a gradual decrease in the range rate. The system may or may not break lock. The scope is free of noise, since range deception uses a gate-stealing deceiver, not a jamming transmitter. Angle deception is sometimes combined with range deception. You use the same countermeasures against range deception whether angle deception is included or not. If the radar breaks angle lock, try polarization changes and reacquire the bogey. If he doesn't break angle lock, use the equipment's half-action rapid relock feature to put the range gate back on the true target. Go into manual track if all else fails. Note that in full manual operation, both target and range tracking gate must always be visible. When used properly, the AERO 1A can defeat most known jamming techniques. Remember to try for a lock-on as soon as you can, so you'll have as much time as possible to decide what jamming method is being used and what the best countering technique is. This is a typical ECM transmitting pattern. Changing attack aspect may allow you to reduce ECM effect because of holes in the target's transmitting pattern. Always try different polarizations. Learn as much as you can about enemy jamming techniques. But keep in mind that this is an ever-changing game. Expect the unexpected. If one countering method doesn't work, try something else. Use imagination and initiative. But don't expect the equipment to do the job for you. Only you can tell what the enemy is doing. Only you can decide what to do about it.